Maybe now. Can you hear me now? Let's see here. Oh yeah, you should be able to hear me now. But I can't hear myself. All right. Oh, I see. I'm just really delayed here. All right. A few more little tweaks here. All right, that should be a little bit better, and hopefully I'm in sync. Oh shit, that's not quite right, is it? Okay, so the video is lagging a little bit, but I think I know why. I think it will correct itself. I hope. Okay, so I think I did have some technical problems, some very serious problems. Called my ISP and everything. Trying to get it figured out. I think I corrected the problem. Don't know why it happened. Still got to research that, but I did fix the problem. So, yeah, I'm gonna have to do a little bit more work, but I don't have time right now. It's still over 13 degrees, so I think I have a little bit of a window here that I can finish up this project, and we'll get it. I got to type something in here. Let me type this in just 1 second. 1 second. All right, let's see if we can do that. So we can. I left something else hanging there. All right, so now we're back onto this. All right, so this is part 3. This is part 3 of building a buzzer. I did part 1 on Saturday, started part 2 this afternoon, and that aborted, and so we're starting part 3 now. So this should hopefully I'll be able to get this thing figured out and done and working and all that stuff. So, all right, and while I was doing all that other stuff, I found some more other hardware to try to make this work. So, all right, what I'm going to do is I'm going to flip this down, show you what I'm working on here. There we go. Hopefully that's pretty much in focus. Hopefully. So I found a screw here that's a flathead screw, and that should set right on there really good. Oops. So that'll sit on there. Now the only thing is that this is higher up on the. See, it's not. If I put that over here, this won't line up properly with this. See that? It's not lining up. So what I have to do is get a spacer in here, and move that screw over a little bit. I found a screw that might work for that. So I'll drill a hole, put that through there, put a spacer on it. In fact, I might even need a spacer. I don't know. Yeah, I'm gonna need a spacer. I'll put a spacer in there, and hopefully that'll be right there. Then this guy will have to move or twist or something like that. I might figure out another way to do that, and then it should work. Okay, so that's what we're doing. I got to find a spacer now for that. So let me do that. I'm gonna run in the next room, and I'm not gonna be able to find a spacer. So I'm gonna build a spacer. I'm gonna make a spacer. So I got an old pen, and I've removed the inside of it. See, old pen. Remove the inside of it, and it should be, once I get it trimmed down, it should work as a spacer here. Oops, that didn't work too well. All right. Trim that up a little bit. I think I needed this to be about that tall. So let me trim it off there. You see that? So you able to see that? So I need a spacer, right? I got this thing on here. I want a spacer to have this thing up a little bit higher. Can you see that? See? So I'm going to put a spacer here under this. And so I stuck that there, and I did a super precise measurement here. See, like that. There. Look at that. I measured it. Now I'm gonna cut it with this tin snips, which, okay, I don't want this piece to go flying all over the place, because that's the piece I want to use. And I'll just snip it. Okay. So now I have a spacer. I think this will go screw in there. Oh shit, maybe this is not the right size for this. It might not work. Okay, I don't think this, I got the wrong size thing here. I thought that was going to be a little bit bigger. Alright. I gotta go find another spacer, another pin. Okay. I don't know what this is. This is some, what brand pin this is. It's a knockoff of Bic, I think, or something like that. So that'll work. All right, that'll work. I should have done that to begin with. All right, so I'll take another precise measurement here. Right there. And I'll trim it. Now this is gonna, without chopping my finger off. Okay, good. 1, 2, 3, 4, 5. Okay, that worked. And that fits in there. That's good. Okay, so, and that's about the right height here, I think. Can you see that? Is that, you guys able to see that okay? There we go. So that's perfect. See, that'll work. See how that'll work? See that? There. So that'll work really good. So now what I got to do is drill a hole right about here. In that thing. Mark where I want to put that hole. Right there is where I want to put the hole. Okay, the hole's got to be this big. All right, it's got to be that big. So I'm going to find a drill bit that's at least that big. Here's a drill bit. That's too big, isn't it? Yeah, that's too big. So I'm going to go find another drill bit. Okay. All right, I got a drill bit, I got a drill. So I think I can do this now. Okay. I usually like to make sure that the drill is unplugged, you know, before I adjust this and change bits and all that. I just think it's a good idea to do that. I don't always do it, you know, but you really should, you know. Make sure it's unplugged before you mess around with it, because it's so easy to just accidentally hit this trigger and the thing will, you know, drill a hole in your hand or something, you know. So you gotta just, you gotta be careful with that kind of stuff, I guess. All right, so let me plug this in, see if I got power. Okay. Make sure I got audio here, make sure I'm not talking to myself. All right, that's good. All right, so what I'm going to do is I'm going to drill a hole. Let me get my mouse out of the way. So I'm going to drill a hole right here in this board. I'm going to turn down the audio a little bit, my microphone a little bit, so it doesn't rattle everybody. So you can still hear me a little bit, probably, very softly. And here we go. We drill a hole now. Let me measure twice, right? Measure twice. How's it is? Cut. Measure twice, cut once. All right, that looks like that's right. Okay. Okay. All right, and I unplug the drill. The drill's unplugged. All right. And so this is the screw that we're going to do. I'm going to work as fast as I can. Oh, let me turn up the mic here so you can hear me better. I'm going to work as fast as I can here and just talk as I'm going along. But because it's dropped down to 13.5 degrees in here already, so that's not good. I want to get done. Oh shit! I've got I should do a countersink there. That's okay. We'll do it without a countersink for now, because I got to get this done, or else I'll freeze, and I don't want to freeze. Let's see, put one in here, and this one. I've got two of these nuts here that fit. All right. Screw. I don't have. I've got somewhere I've got sockets and wrenches, open end wrenches, and I don't know. Maybe that might work for this, but it's just so much easier to do it this way. All right. There we go. Well, that's pretty good. Could probably be a little bit lower. Yeah, you know what I should put? I'm going to trim that a little bit more. because I Alright. So we'll trim that back a little bit more. Do this as quickly as possible here. No, okay, that's not. Oops, wrong one. Alright. That's kind of sideways, isn't it? It shouldn't be like that. Alright. Get that back on there. Alright, that's about right. Once I get that other one on there. Actually, could be a little bit more, but I could probably just. Keep doing this, it'll screw will countersink itself here. All right, perfect. Okay, I'll put another one on here. Is that the one? No, this one. Probably actually have a different washer on there, but that's all right. So we got that, and let's see. This is where I'll put the plus, right? Isn't that how I did it? I forget it where I had it plus and minus, but so I put the plus over here. And I don't have to run it through those resistors anymore. You can check out the earlier streams where I explained what was going on with the resistors and all that. See, that'll work pretty good, I think. I might have to bend it a little bit to get it started, get it close enough, but I think that'll work. Let me hook up this power supply just to see if that actually pulls down or not. So, all right, first we will. Oh, I know what I did wrong here. This should actually be. Yeah, there should be minus on this one. Plus goes over here. That's how I had it. That's right, because I was running it through the resistors there. Can you see what's going on there? Get this damn thing out of the way. Alright, so I'm connecting that. And I'm not soldering anything with this project at all. I'm not really worried about it. I'm just wondering, it's kind of an experiment, you know? It's not. I probably should do something to make the connections better, you know, because it is kind of sensitive to to resistance, bad connections or whatever. But that's okay. All right, so I think what I'll do is I'll just touch it here and see if it goes down that way. That way I won't have to mess with it for right now. I just want to see if that magnet works, at all. So I'll touch it to here, and we'll see if that works. Actually, I think I'll use the pliers to do that. All right, so I'll plug this in. This is the power supply. Okay, so the power supply is going now. Crank it up a little bit. I'll touch it here and see if that makes that thing go down. Oh yeah, it's moving a little bit. It's moving, but it's not... It shouldn't be buzzing like that. I don't know. It's a problem with my power supply here. Maybe I'm not getting. I don't want to pull out my O-scope. That's a big pain in the butt. I've got a really old oscilloscope. It's not too good. It would be a pain to have to bring that out and hook that up and figure out what's going on. Just to figure out what's going on with the power supply, But it is going down a little bit. But that does take quite a bit of spring to get that down. So let me try a little bit harder here to get this bent. There we go. Why is that not springing back up? That's kind of weird. That went down and it didn't come back up. That shouldn't be permanently magnetizing that magnet at all. Huh. Let's get in the way here. Well, that's kind of blurry. I just looked at a better monitor here, and that's really blurry. Oh my. Was that blurry like that all the time? Let's see here. Let me see if I can adjust that, make it a little bit more in focus here. I don't have it on autofocus. I have it on manual focus, so it shouldn't be trying to autofocus at all. There we go. Okay, that's pretty good. Ah, that's great. All right. Okay, so let me click OK here. See that? Did that mess it up? No. Okay, I didn't mess it up. All right, so why is that? I have to put it. All right, this is going away. That's just getting in the way. All right. Make sure I'm touching it. It's so hot here. You know, it doesn't even have to actually touch that, does it? I just realized that. It doesn't have to actually make contact with the electromagnet, right? If it just goes like that, that'll work, right? That'll ring the bell. Let's see if I gotta... Want it? Yeah, that'll work. Let's see if that works. So that'll work. All right, I think it's gonna work. I think it's better than what it was before, at least. All right, so short this out. Get that capacitor gone, so I don't shock myself. And then we got to make this, you know, power this when this is up or down or whatever. So let's see how I can do this here. Oh, and I want to put that diode in there. Right? So let me figure out which is forward on this diode here. I forget what the nomenclature is on this, if the line is for minus. I think the line is for minus, so that's what I'm going to try it. Let's make sure it works that way. And then I'll put that diode in the circuit. All right. So let's see if that works. Yeah. So that's forward biased. So that's minus. So what I need to do is put it this way then, right? Across that thing. Then it will be reversed normally. Alright, get rid of that capacitor. Alright, so that's minus. So if I put it this way, so I got it reverse biased across that diode, that should work for me, right? It should work to suppress those sparks. I mean, they're kind of fun, right, to look at the sparks, but you know, it's causing problems. It's pitting and causing carbon deposits and everything else on the contact. So it's you know, it's not good. It's Jesus, what a pain in the ass this is, huh? Why is that not doing what I want it to do? You know, I wasn't going to do this stream at all. And I was just so tired. I just ate, and I was just really, really tired. I was really sleepy. I was ready to fall asleep. And the sun came out. And I thought, oh shit, I got to do the stream while the sun, because the sun's going to heat it up enough in here that I could do this. But I'm really tired. And just not functioning too well right now. God, I don't know if that's going to work or not. Alright, whatever. Got that side in there. Now I'll stick the other one on this side. God, I can't believe how these leads on this. Well, this is a 3 amp diode. I hope that's going to be enough. I popped a meter that was a 15 amp meter with the same kind of circuit. So maybe I'm going to pop a diode here too. I don't know. I'm not really sure on the kickback there what that's going to do in this situation, but we'll try it. And then I ran into that technical issue that was a big hassle. I started this thing, so alright, let's see what that does. Alright, we're going to start the power supply. Alright, you got everything in there. The diode is reversed. See, it's reversed biased. This is the negative side of the, when it's forward, when the diode is forward biased. This is the negative side of it, and this is the positive side. So what I'm doing is I'm hooking this up backwards. So I'm going to hook minus here, and this is plus across the thing. So it should still power the coil when I put the power on it, but when I release the power, it should make less spark. That's the plan. I mean, that's why I'm doing it. See if it'll make less spark, and hopefully it won't blow up that little diode. Okay, power supply is on. I got my negative here. And we're going to hit it and see what happens. Okay, it's making the thing go. I'm still getting sparks a little bit, but maybe not as much. Maybe I've already popped that diode. No, they usually pop pretty dramatically. You can tell when they go. All right, so that, I think that'll work. So now what I got to do, what I'm thinking is to put this. All right, I just connected the power now. I was thinking I could put this on like a plate or something right here. Or I can just connect this to here. That's what I should do. Is just bend this whole thing over and use that as the switch, as the contact. That's what I do, I think. It'll reach. I don't know if it's going to reach or not. Well, that'll reach, I think. Yeah, that'll work. Make contact there. It's not making contact there. Okay. Then what I'll do, that way I won't have to. Before I was using this strip here as a conductor. You know, I was hooking it up over here, and in the contact would have to make contact here and go through all this. And so what I'm going to do is hook the wire up here instead, and hopefully that wire is not going to mess up that springiness of that spring steel too much. So that, I think that'll work. Then what else was I going to do? Oh, we got to hook the bell up. Yeah. What time is it? 5 o'clock, 6 o'clock. Okay, we don't want it to get in the way of that thing, that nail contact there that I'm using. Don't want it to be in the way of that. All right. You know, I'm using all this scrap stuff, so it's like it's not really designed for, you know. It's not even this. You know, none of this stuff is designed for electrical, you know, or any of this stuff. So it's kind of all right. There we go. Now I've loosened that where that nail is now, so it's kind of. We need to do another nail there. That might work. I don't know. All right, let's try it. See where we're at here. See if it does anything. Okay, so we got got it hooked up here, and I've got this. Now this nail is going to act as this contact on this thing, and when it energizes, okay, that's still not right. That nail is in there too loose. Okay, I'm going to move that nail. I'm going to put a whole new nail on there. Pull that out completely. rusty nail in there. The contacts that aren't too good. And I'll pound it in over there. All right. All right, so let me put that nail in there. Turn down the audio a little bit so we don't irritate people too much. Okay. I bet you've never seen anybody work on electronics this way, have you? With a hammer? That's pretty good. Let's see here. A little bit more. All right. Now I got to try to bend that. Right here, right now. So I want to bend that over so it makes contact with that doohickey there. There we go. Oh, that's just about perfect, isn't it? That'll work. Well, I think that might work really well. All right. Let's see if that works. One more time. Try plugging in the power supply. And see if it goes. All right. Let me turn up the mic there. Okay, so I got it. That little guy is in there pretty good. Can you see that? Can you see that? You can see that pretty good, right? See how that's... When I do it, it should pull the guy down like that. And that should work pretty good. All right. You know what? I'm going to kill this browser here, because I think it's causing my stream to delay a little bit. All right, there we go. All right, here we go. We're going to try it. Ready? One. 1, 2, 3. Go. Look at that. Amazing. Yeah, didn't work. I got nothing. Okay. What did I do wrong? I think power supply was working. Capacitor was charged. Okay, the capacitor is fully charged on the power supply. That's what that spark was. Which tells me that it was not getting anything in there at all. Let me try it again here. It isn't working out to get the meter out and figure out what's going on. Well, I hear a hum when I plug it in. You hear that hum? Oh yeah, it's trying to go. Okay, I think I know what the problem is. Let me short this out here. All right. So it's it's not. It's got too much spring in it. It's not. The magnet is not pulling it down. So that is not. It's hardly anything. That magnet should be able to pull that down, but maybe not. I'm gonna try bending this down a little bit more, so it's closer. You know, so the whole thing is closer to the magnet when it's making contact there. Okay, well that's right on. There's no room for it to move at all now. All right, at least we got it so we can adjust it a little bit now. There we go. All right, that should work. Let's see. Well, we got a spark. It's trying to go. I got a buzzer. All right, I gotta work on that a little bit more. All right, so what I think I'm gonna do, is that getting hot? Yeah, that's getting hot. It's a little warm. Okay, that diode isn't too hot. It's a little bit warm, but it's not gonna, okay. I gotta do something here real quick. Take care of something. More technical stuff, kind of. All right. Okay. All right. I'm got do some stuff on the keyboard here for a little bit. So hang tight, everybody. So that's, I think what I'm going to do is I'm going to test it. Just test that magnet just to get a feel for what what that magnet is doing. So I'll put that over there. Turn this on, and so that's connecting to the thing right now. I mean, that's pretty strong. That feels strong to me. It is vibrating, which tells me that that cap is not big enough on that power supply to filter out the AC. It's vibrating at, like, 60 hertz, so it sounds like it's I might need another power supply to make that thing go. So that's a possibility. Yeah, let me try that. Let me put another power supply in there. Alright, that's going through that. Okay, so what I could, there's a couple of things I could do, but I think it's the power supply is vibrating. It shouldn't be doing that. Let me get another power supply in there. So that will be, that might help it. Yeah, I made all those modifications to that power supply. But I just put this little cap in there. I'll show you this. Here's that power supply, right? I slapped this fan on there and drilled holes, and I made this little put a bridge on here for this is for like 4 diodes, for a 4-way bridge, and then hooked up this cap. This is a big cap. It's 10,000 microfarad, so it should be filtering out stuff, but there's quite a bit of load on here, and that, who knows what that inductor is doing to this whole setup here. So, and there's no regulator or anything, right? I'm just filtering it. I'm just, making the waves all go one way and then filtering it, so it's not that big of a deal. And my other power supply is, I think, is a little bit beefier than that. It has a bigger transformer on it. Yeah, the other power supply has a bigger transformer on it, and I don't remember what. I think it has a bigger cap in it too. I mean, it's physically bigger, but it's an older cap, so maybe it isn't as anyway. So what I'll do is let me run and get that other power supply if I remember where I put it. Then I'll bring it back out here and we'll hook that one up. Yeah, we'll do that. I'll be back in 3 seconds here. Okay, so I put when I built the thing, I put 4.5 amps is what I rated it at. So I don't know, it's going to pull more than that, I think. Hopefully I don't pop this thing. I built this a long time ago. This power supply here. Something's loose in there. Maybe I should open that up and see what's going on. That's probably just the cap. But I built it a long time ago. It's got a big heat sink on here and everything. I don't know what's going on here with this. I think that's just the capacitor. I don't have it nailed down in there. All right, get rid of the old power supply. Out with the old. Oh wait, we got to do this. Let me see what I'm doing here. So get rid of that, and get rid of that. All right, that power supply is gone. Off to the side. So we got another power supply. This guy's going to go over here. Oh, this one's got little connectors on it. Oh boy. Let's see here. How can I do this here? Well, for just for now, I'm just going to hook this up just to see if it just to see how it does on that electromagnet, to see if that thing even works at all. Oh shit, I just lost some hardware down there. That's important. Alright, there's positive. Oops. I don't want to snip off these leads of this power supply, so I'm just going to shove that in there for now. See if I can get a connection. There we go. Alright. And minus. I may have to get a well, I can just hold it on there, right? And just to see what it does. All right, let me plug this power supply in. Plug it in. And then we'll hook this, touch this to there, and see what it does, right? If it sparks, that means we probably have power. All right. Oh yeah, that's better. There's a little bit of buzz, but it's definitely stronger. All right. So what I've got to do is, I guess I could clip this end of this and just use that. Let me do that. I don't need this thing on there, right? I don't know what this is, what this actually is from, this thing. So I'm just going to clip this off. Strip that. And oh, this is the minus. Oh, this might work. Might actually cause problems for me here. That's okay. Stick it under there, and I don't know how to get that up so I can get under there. I'm really wearing the wrong glasses for this too. These are, you know, when you get older, you need like 20 different types of reading glasses depending upon what distance you are from stuff and everything. Kind of pain in the butt. Don't get old. If you have the choice, don't grow old. Actually, you might keep getting new technologies and stuff. It might actually be a choice one day. People might have a choice to grow old. Oh shit, did I leave that powered on? Oh, that was just a cap. Okay. Should have discharged that. So right now I'm just trying to get that adjusted so it will be far enough away that it will. All right, there we go. All right. That'll work, huh? Is the power supply strong enough? I think that's what it was. Is that other power supply was just, you know, I had modified it to try to get more out of it, and it was just saying, nope, no, I don't want to give you any more. So, all right, let's try this. Ready? So we're gonna. I gotta do something here. Okay. Oh, let me make sure I've still got an audio here. All right, I think I've got audio. Okay, here we go. We're going to try it again. Test number 47. I don't know what number it is. Gazillion. There we go. Look at that. Oh, damn. All right. Oh, all right, we got something. Oh, I see what's going on there. Bring that out just a little bit. Out away from that. I just want to get this working. It's not, I'm not building this like, you know, to actually have the thing, you know, I'm just doing it as just for fun. I guess we've already done the theoretical stuff, so this is kind of just arts and crafts right now, you know. So, I don't know. I'd like to see it actually work. So. All right, so I just applied power to it. It didn't want to run, so. So maybe I did pop this power supply. I don't know. Okay, that's 41C. That's 41. So that's still, it's not like frying completely. Try again here. I'm not getting anything. I may have popped this power supply. All right, so we gotta troubleshoot the power supply here. Get my meter out. All right, so we're gonna bolts. Hey, there it goes. All right, I don't know why that did that. That seems to be working really well. Wow. Okay. I must have jiggled a wire that was loose or something. I don't know why it started working there all of a sudden, but it did. That's up to 100 now. So that's probably about the limit on that wire. That enamel wire is at 100 degrees C, which is probably about its. Well, I think the lowest limit on enamel, like magnet wire like that, is 105 for the lowest reading. I have no reason. I have no reason to believe that this is a higher rating wire. I don't know what it's rated at, but so I'm running it right at the limit there. I won't be able to run this bell very long, you know. At least we got it to go there for a little bit. And this is kind of, this nail is kind of hokey. That should be a bit better. Let's try this again here. There we go. All right, well, we got kind of halfway going there. I'm starting to get bored and impatient with this, so I'm just going to finish it up. I'm going to stick the bell on there. I'm getting bored with this already. I'm going to stick the bell on there, and if I can get it to ring for 10 seconds, then I'll say great success, and I'll move on to stream something else, because I don't know if this is boring for people or not. But I'm starting to get bored myself, so that's not a good sign. The streamer's bored with his own stream. It's probably boring to other people too. All right, I can put it in there this way. Let's see how I can do this here. Or I can do, I'll do it this way. I'll put it up this way. All right. So I disconnected that. We got to short this out. Make sure the cap is shorted out. What do we got going on here? Make sure that cap is shorted out. All right, I guess it's shorted out. All right. And so we'll drill this thing. Drill, baby, drill. Put that right about there. Okay, that's where we're going to put the hole. I'll drill a hole right there. Not with my screwdriver, with the drill. Let's see, I got to make it this size. What I'm thinking is maybe I could make it really, if I make it close enough. I don't know. Let me find that drill here again. Oh, I wasn't showing you what I was doing there. Sorry. I just took this bell here and I lined this up. I said, okay, it should go right about there. And I put the screw through there and said, okay, where's it going to go? It's going to go right there. That's where the screw's got to go to mount the bell. That's what I was doing. So now I got to go get the drill again. Oh, I think this is the right. I actually have the right size bit on there. I think it was pretty close to the same thing. Yeah. Yeah, it's a little bit bigger. Oh, that's about right. Okay. So that's what we're going to do. I'm going to drill a hole for the bell, to mount the bell. Turn down the mic a little bit and drill a hole. Turn it down here so you can watch me drill the hole. You ready? Here we go. Wow. Let's try harder. Now we're gonna try it with the drill plugged in. See if that works better. Probably will work better when it's plugged in. I'm just guessing. Okay. So I guess I can countersink. I'm not gonna. I actually could do. I don't have to countersink that. Let's see. Okay. All right, put that through there. Kind of halfway countersunk. Not exactly. That's a bigger one, actually. All right. That size? No. Now I gotta find a nut for that thing. I think I used up all the nuts on that other side over there. Oh, this is going to be a challenge, finding a nut for this thing. No, it's the wrong size too. Might be the right size. No, I don't think so. Let's see here. No. Yeah, I actually used up all my, I think this is number 10. Boy. Oh, there goes that one. That'll work. No, it's wrong. Long thread, so that's probably a metric or something. Yay. Okay. Yep, I gotta go find a nut that's gonna work for that. Let's see, can I borrow one from that? No. Oh, here we go. Is that one? That might work. It's a lock. It's one of those nylock things. So, don't know if that's going to work or not. Let's see here. It's a slotted screw. I can't believe they're still making slotted screws. That's going in there pretty rough, pretty hard. So I don't know if I've got it cross-threaded or if it's just that nylon locking thing. On that. Shit. All right, let me go. I'm gonna have to go on a little search here and see if I can find a nut that fits this thing. or another screw in that. That'll work. Well, heck, I hate when that happens right before a stream. Okay, dinner's going to be a bit late, so I'll hang with you for a little while. Oh, thank you, Ducky. I've got Big Ducky Snow in chat here talking with me. Yeah, I'm sorry. I tried to start my stream and then be able to lurk your stream while I was doing my stream, and I ran into. Let me turn this up here. Yeah, Stephen, I wanted to start my stream because I don't know if you were here when I explained that it got warm enough in here that I could do my stream, and I wanted to get it done really quick, and then I ran into those technical problems. And I was just going to lurk your stream while I was doing my stream, and the whole thing got messed up. So what I'm going to do right now is I'm going to do a be right back. I don't have anything to, do I have anything to play here to keep people entertained? I know what I'll do. Yeah, I'm gonna see if I can find a little video for you guys to watch or something, just so you don't have, because this might take me a minute or two to find the right hardware downstairs in my basement there. So let me see if I've got something here that would be interesting to watch while we do that. You want to watch a movie? Here we go. Driving scenes. Here we go. Perfect. Okay, this will work. No, that's not it. Let's see. Mozilla. I don't know. Boy, they don't make this easy, do they? Oh, here we go. Okay. Can you see that? Okay, good. All right, we got that. So there's some. These is me driving around in the springtime or wherever, no, fall, around where I live. So you can watch that while I go, and I'm going to try to find, a screw and nut or whatever for this thing. So I'll be back in a little bit. Can you see my be right back sign? Here we go. All right. I don't know if this is going to work or not. We're going to try it. Well, that's just going to barely fit, I think. Oh, boy. Okay. Well. All right. So. All right. I couldn't find, believe it or not, I could not find. This is a 1024 thread. I mean, it's like about the most common thing you can find. And for some reason, all of my nuts don't fit. I may have messed up that thread, so maybe that's what's going on there. Anyway, so this is not going to go. I can't use this original one that I had here. This screw. I found another screw. It's a number 8, I guess. I think. So we're going to do that instead. So let me turn that down here. And so I got this. It's skinnier, so it's got the wrong size hole. Blah blah blah. You know. But it's gonna make it work. I did find 2 nuts because I think that's all I'm gonna need to do this. There's 2 nuts, I think. All right, got that. Is that a slotted 2? No, that's a Phillips. They still call them Phillips? I don't think they call them Phillips anymore. I think they call them just plus and minus or something. Well, the good thing is that looks that's going to countersink a little bit better. In there, okay, so that's in there real good. Now, is that going to be tall enough? Just barely. All right. And I can put, I think that's going to work. It's just barely tall enough for that. Hey. And that just needs to be, I don't want that to actually be too tight, right? I want it to be able to ring. All right, let's see if it works. I don't know. Let's see if it works. Got some beautiful places to drive in New Hampshire, Ducky says. Nice. Yes, we do. It is beautiful. What exactly is that device you're making? I'm making a bell and a buzzer. And just start out with a buzzer and then turn it into a bell. It's an electronic. I don't know if you've ever heard of what an electromagnet is. It's a magnet that when you put electricity, it's basically a coil of wire, and when you run electricity through it, it makes it be a magnet. And then the magnet pulls this thing down to ring the bell. See? And when it pulls it down, then this little switch here disconnects the magnet, which makes it go back up again. It just keeps repeating that, keeps going up and down and up and down and up and down like that. See? It's a bell, basically, is all it is. I talked in the first stream. I talked a little bit about the science, but not a lot. You know, I'm trying to make this kind of not too technical. So this might just run. Let me turn it. I'm going to plug it in. This is a big test. We'll see if it works. If I get this to work for 10 seconds, and I'll consider it done. Let's see if it works. Nope. All right. What do I get? A disc. Okay, this was disconnected over here. Okay, let me, I forgot to hook this up again. I think this is where I had that plugged in. Let's see. Over here. Also, I've got a charge. That cap is charged right now, and I shouldn't be really doing this because I just turned it on and it didn't go, and so I turned it off, which means the cap is still charged. Let me discharge that. We're going to discharge that. Right there. There we go. Okay. Did you see that spark? That's because that cap was charged. So I want to be, do this safely. This is only 12 volts, but because I got this coil on here, that coil does some special stuff and makes it a lot more, higher voltage and higher current and all that. So you got to be a little bit more careful when you mess around with inductors, even though you're working with low voltage, because the inductor can make it higher. God. I should have went and tried to find like actual connectors for this, but there we go. Okay. All right. One more time. Didn't line that bell up too well, but that's okay. Okay, it might work. Let's see. Oh, it's trying to work. That didn't count, does it? There we go. Not sure why that's not going. There it goes. Oh, it's starting to go by itself. Oh, look at that. Almost. Is that ringing? It's almost ringing. Does that count as ringing? Watch Double Tribble's cool video. Oh, that's my bots too. Will you use that device for any everyday? No, I'm not going to use it for any. This is just for fun, just for learning, and just to see if it, just to see if I could do it. It's more of a learning thing, but I can't. I think what I'm going to have to do is do those connectors a lot better or something. I'm not sure. So we almost got it to ring there. The problem is my connector, I just have these wires not connected very well. I just want to get it to ring once here. Oh, that almost did it. I know what I got to do here. Let's short this out. It's already shorted out. Yeah, it's so close here that I just almost got it. As I said, if I can get this thing to ring just for 10 seconds, I'll consider this project done. Probably could have made a lot better choices on a lot of these things. You know, I just wanted to get it done. Let's see, this should be a screw or something up here. This thing. Oh, see, that'll work if it vibrates here. Let's see. Almost. Are we supposed to see so many sparks? Yeah, that's part of the thing. I put this little device in there that I thought was going to help make the sparks go away. But, well, there it goes. It rang, I think. Let's see. Oh. All right, I'm gonna see if I can put that connector on there a little bit better. Get that. Let me go find a connector for this thing. Again, with a spade connector for this guy, and I'll wire that wire directly under it, and that will make it a little bit better. So I'm going to run just into the next. This should just take about 2 seconds to get this. So, be right back. Okay. All right, I found some spade connectors. And what I'm going to do is I'm going to crimp those onto that wire there, and then we'll have a real good connection. I hope it'll be a good connection. So this is a female spade connector. It's a male connector, and look what they do. And so I'll shove those wires in here. They look like they're not going to fit, but I'll make them fit. And this looks like this has got, this connector here looks like it's got some, I've got heat shrink over the top of it. So it's going to make it so it doesn't fit too well with this. So let me trim away some of that off of this guy. See what I'm doing here? Trimming away that. All I gotta do is just pull it out of the way, right? That's all I gotta do. And so these two connectors should go together like that, and they do. Okay, good. So that should make a nice firm connection there. Now I gotta crimp it onto, whoops. I gotta crimp it onto these wires here. Let's see here. That diode really isn't doing anything, but I'll just leave it in there anyway. I think that's in there far enough. Alright, so I'm going to try crimping this connector on here. Didn't work. Okay, I screwed that up. Try again. This has got a little bit of insulation here that's keeping me from pushing those wires all the way in. And it's really not the right size for this thing, but I'm making it fit anyway. There we go. All right, let's see if I can. I should just let me just take this whole thing off. We'll just do it this way. It doesn't need to be shielded or anything. Yeah, see, it's for the wrong size wire. Which is a problem. I guess I could try to get just one of those wires in there. That'd probably be good enough, but see if I can get it in there. There we go. Okay, I think I got it. All right, now I'll crimp that on there. Actually, that's not how you should crimp it this way. Use the right crimper thing here. Okay. Finally. All right. I'll take care of that. And we're unplugged, right? Yeah, we're still unplugged. Okay. All right, there. So I've got that hooked on there. That should be a little bit better, firmer connection, whatever. I don't know if this is gonna. Thanks so much for your wonderful company and chat. You and your streams always help pick me up. Well, thank you, Stephen. Dinner time for Ducky. Okay. All right. Enjoy your dinner there, Ducky. Hope it's good. All right. I don't know. All right. I think it's going to work. Right. Positive thoughts here. There we go. Hey. Not quite hitting the bell. Okay, this just needs to be twisted just a little bit down here. That's probably too much. Okay, here we go. There we go. I hear a bell. You hear it? Well, I think I heard a bell. I think that was good enough. Stephen heard a dinner bell, so he went to go eat dinner. So, I don't know. Yeah, this is good enough. I think we learned something. We learned not to do this project anymore. That's what I learned. Okay, I think it worked good enough. You get the idea, right? I'm just wasting time right now. All right, so that's how that works. There's one other thing that I wanted to explain. Yeah, I didn't do that. Yeah, there's one other thing I wanted to explain. So let me bring up this thing here. I didn't study it actually enough really to explain it, but I'm gonna try to explain it anyway because that's what I do. Yeah, I don't really care. Yeah, I do. I care. Let's see here. see, that. There we go. Okay, did that work? It's not showing up on my, oh, there it is, okay. Something came up when in last stream, the first stream, part 1, and we were talking about the magnetic fields. Let me do new here. Let's see here. New, white. Okay. Make sure I got audio here. Okay. So, like, if you have a bar, say I'll just use a bar magnet, right? Got a north, south, and it makes these lines of force that they refer to it as the magnetic field. They're vectors. So it's actually going from south to north. So it's going to have an arrow on it because it's a vector. It's going in a direction like that. And the same thing down here, saying all the way around. And those are vectors too. And you get a whole bunch of these lines, right? Doing this thing. And you've probably heard the word flux before. And flux, the magnetic flux is if you take these lines here and suppose you put like just a plate here, a sheet, okay, two-dimensional thing, and it would go through at these points here on this thing, and with the flux density is it's a surface integral of the vectors, the electromagnetic vectors, or the magnetic vectors going through there. But it's basically how dense are these things, you know? And they're not even. That's why you got to do an integral. But it's how close together these things are, right? Going through this sheet, and these aren't just in a line. Some of them are going, you know, here maybe, and then this one maybe goes here. You see what I'm saying? And then comes out like that. So there's a density here where all these little lines go through this imaginary sheet, two-dimensional sheet. So that density is called the B field when they talk about the B field. And I hope I got this right. Somebody tell me if I got it wrong. But that's the B field. And then there's another one. That's the H field. I think it's capital H. And that refers to how strong these vectors are. The vectors themselves are. So there are two different parts of the magnetic field. One of them is the B field. That's the density, the flux density going through a thing here. And the other one is the H field, which refers to how strong these vectors are, each one. So I hope that's my understanding. I hope I got that right. Because that came up it didn't actually come up. I thought it was going to come up. Somebody mentioned that in chat. Mentioned B. I thought he was talking about the B field of the magnetic field, yeah, but he was talking about something else. But it made me think about that I really didn't understand that, and I looked it up. and I read it, and that's my understanding of how that works. Now, I was going to look at a video on that to see if I could to understand it better, and I just ran out of time. But I think that's what that is. I'm pretty sure that's how it works. And they have equations, you know, all kinds of different equations that you can use to figure this stuff out. But I won't go into that. But if you ever hear anybody talk about the B field, a lot of times they just only refer to the B field. But there's a B field and an H field. And there are two different kind of aspects of the magnetic field. So I just wanted to explain that. And that's it. Okay. So I don't think there was anything else. So I kind of got it to ring. I'm getting bored myself with this, you know. I don't have the patience. Some things I will work on, you know, if I'm learning something or it takes a lot of you know, a lot of brain power to do something. I like doing that kind of stuff. But this is just you know, it's not taking much brain power. This is just mechanics, you know, and just trying to get the thing to work and all that kind of stuff. And it's just, so we do have a bell. I can make the bell sound. Well, that's close enough. It did kind of make a bell sound there for a little bit. It sounded more like a buzzer, but it was kind of a bell too. I don't know. But anyway, we learned how those work. That's the, you know, we learned how electromechanical bells work, and there are other ones too. I was going to build one out of just a speaker, you know, have a little oscillator circuit and make a speaker go. But that's just we don't need to do all that. I mean, that's how they do them nowadays. Anything that's going to need a buzzer or, you know, a bell or buzzer or anything like that is going to have some sort of CPU in it that you can just use to you know, it'll have a port on there somewhere that you can just run through you know, an amplifier of some sort that'll make that speaker go. And you know, they just use piezoelectric speakers now, I think, usually, unless, I mean, like, you know, we've got speakers on our computers, right? But that's a different thing, and they can make those beep and stuff like that. But like when you first turn your computer on, you hear a little beep from the motherboard. There's a little piezo speaker on the motherboard that makes that beep when you first turn it on. And the way they do that, they obviously don't use this, right? They don't use it's not one of these things in your computer. They just use they just tell the CPU just, you know, makes something beep. They either have a dedicated oscillator in there to do it, or they just have the CPU click that port, you know, at a certain rate to make it beep. So, but this is kind of cool because this is how they used to do them all the time. This is how they used to. And another thing is that this is very much like you know, Morse code. What the hell are they called? Oh my God, I'm blanking out on this. You know, where they have a switch. I was going to put a switch on this too, but they have a switch. I got to sneeze. Not telex. What am I thinking here? Telegraph. So they would have just two, you know, a switch of some sort, instead of having this automatic switch here that comes on and off and on and off. They would just have a switch like I was doing earlier, just turning this thing on and off. And you can run those wires as long as you want, and that's how a telegraph works. Is, you know, they use Morse code. They push the switch on and off. That completes the circuit, makes this electromagnet go, and it goes tick tick tick. And the guy in the receiving end just listens to that and can tell the Morse code from what they're doing. That's how telegraph worked. And it was a big deal when that came out. I mean, that was, you think about it, the only way they had to communicate back then was somebody carrying a letter, Somebody have to write something down, hand it to somebody. And before horses, they had to run. They ran, to deliver it. And then they got horses, and they didn't. Remember Pony Express and all that. Pony Express didn't actually run that long, and they did, and that's how they did it, and that's how they communicated stuff. So it took a long time to communicate. Carrier pigeon. I guess they had those too. Those were a little, probably less reliable, but faster. But when they came out with this telegraph, that was a really big deal, And then they strung the wires, and it was a real big deal to be able to communicate so quickly. And they use it. The telegraph came out right around the time of the Civil War, so Lincoln used that, to his advantage. He had control of a lot of telegraph lines and stuff like that, and he used that to communicate to his troops and everything. Blah blah blah. And it was one of the factors that helped win the war. So, there's a little bit of trivia. All right, so everybody, thanks for showing up and watching this. As I said, it's not going to be on the VOD, so I might make an actual video out of this, which might be easier to watch than this. And what else? Oh yeah, make sure you wear your mask. Yeah, I've got to tell everybody to make sure you wear your mask. We're in the middle of a pandemic. We got multiple pandemics. Actually, we got over 1,000 people a week in the United States die from COVID. Over 1,000 people a week. That's a lot of people. That's over 100. That's 100 and something a day that are dying from COVID. So it's dangerous. It's dangerous to go out in public without wearing an N95 mask. It's more dangerous to not wear an N95 mask than it is to go driving around without wearing a seatbelt. More people die because they didn't wear one of these than die because they didn't wear a seatbelt. So it's very important to wear these. Make sure you get one that says N95 on it. Make sure it says NIOSH. It has to say NIOSH. It has to say N95. It has to have straps that go all the way behind your head. The ones that go behind your ears might not protect you as well as an N95. And it has to make a really good seal around your face, all the way around. You can't have any leaks at all. So please do that. Please wear those when you're in public, so you don't kill old people like me. Okay? Please. Appreciate it. All right. Thank you for stopping by. And everybody take care. Bye.